Example number 7. We want to sketch the function f of x given in the problem 7. And to save the time, I already calculate the first derivative is 4 minus x over x to the 1/3 times x 6 minus x to the 2/3. And f the param is negative 8 x 4 over 3 6 minus x 5 over 3. Okay, so now in order to find the critical point, we learned in section 3.2 before, either f prime, so critical point. So critical point means the local max or local mean. Okay, so we will set the f of x equal to 0, f prime of x equal to 0, or f prime of x does not exist. So f prime of x is a fraction, so equal to 0 for 4 minus x equal to 0, then x equal to 4. F prime of x does not exist when we have x to the 1/3, 6 minus x to the 2/3 equal to 0. Then x equal to 0 or x equal to 6. Now we find the minimum or maximum local by looking at the sign of the f prime. So we have negative infinity and positive infinity. So we have 3 points. So we have 0 here, 4 here, and 6 here. And then we will test in the point. So we will test, for example, you can test negative 1 here, you can test 1 here, and you can test 5 here, you can test 7 here. Now you go to f prime of x. If it's negative 1, then this become positive. Negative 1 to the 1/3. This is a cube root of 1/3. Cube root of negative 1, so it's negative. And 6 minus negative 1, so it's changed to positive. So the answer here will be negative. And similarly, you just plug in the number or input them into the calculator. You will get positive here between 0 and 4, and then minus here and minus here. Okay, so what does it mean is that we have the slope of the tangent line, which is f prime of x, negative. So the slope or the tangent line go negative direction, go down, go up, go down, and then go down again. Okay, so we use the first derivative test, and we can see that when the graph change the sign from negative to positive, we will get the local mean, right? Local mean. And for the 4 from positive to negative, we will get the local max. So in order to find the point for local mean and local max, we will plug into the original function. So f of 0 is equal, so we're going to put 0 into this one, okay? Then we will get 0, and we plug in 4, then we will get the answer is 2 5 over 3. So 4 comma 2 5 over 3. So 0 0 is the local mean, and 4 comma 2 5 over 3 is local max. We do not do that for 6 because we do not have to change the sign between the left side of the 6 and the right side of 6. Okay, so at 6 we do not have local mean or local max. now we discuss about the concave, right? So we will take the second derivative and we let it equal to 0. Then we have then what happened is that because the f the param, we have a fraction. So f the param does not exist when x 4/3 4 minus x 5/3 equal to 0. Then we solve for this, we will get x equal to 0 and x equal to 4. This is 6, it's not 4, so 6. So then 0 and 6. Then we do the number line. Then we're going to put 0 and 6. Then we also do the same thing. We testing the point for f the param. So we're going to test -1 here. We're going to put 1 here and then 7 here. What do we get is we have -8 divided by -1. So this is like -1 to the power 4. So it will change it to positive anyway, right? And then we have -1. So 6 minus -1 is will turn to positive. So the final answer will be negative right here. So we can have negative right here. Doing the same job, you plug in 1, you will get positive in the bottom but negative on the top, so still negative. And then when you put in the 7, you will get this positive. So it's going to be concave down for negative, concave down for negative, and concave up for positive. Inflection point will be what point? Will be 6, because we got left side of 6 is concave down and then it's gentle concave up. So inflection point. So we're going to plug in 6 into the function. So we get f of 6 equal 6 to the 2/3. And then 6 minus 6 to the 1/3. This will give 0. So 6, 0 is the inflection point. Okay. So we got this information for the local mean, local max, the inflection point. So we got those points. So now let's go ahead and make the graph for this function. Okay. So let's put in the point 0, 0. And then we have 4. Okay, 4 and 2 to the 5 to the 5th to the 5/3. So it's about 3 something, 3. Okay, so this point will be 4 to 5/3. So that is the local max. Okay. So let's draw the line so that we can remind ourselves that this is local max and local mean. That is the tangent line over there. Okay, so now we do the concave. So on the left side of 0, we have 0 right here. On the left side of 0 is on the right side of 0 between 0 and 6 is concave down. So it's going to be like this. And the 6 is 6, 0 is the inflection point. So this is the point on the graph also. So we're going to have like this and then like this, right? Okay, so it's concave down, which is this interval right here. And then we will have concave up. That means at 6,0, this is the point where we change from concave down to concave up. So we will have like this. Okay. And then what about the 0 on the left side of 0? The 0,0 is the local minimum, so we should have like this. So we cannot draw like this, okay? Because 0 is the local minimum, and it's a concave down on the left side of 0. So we should do something like this, okay?